Right, so now we prepared our system. We installed DNSMask and host APD, and we connected our wireless adapter. We stopped the network manager. We cleared any rules that might interfere with creating a fake access point. In this lecture, I'm going to show you how to configure DNSMask so we can use it as a DNS server and a DHCP server. And I'm going to show you how to configure host APD so we can start the fake access point and allow people to connect to it. Now, let's go to the first step and let's try to start our DHCP server, and that's also going to act as our DNS server, like I said, because we're using DNSMask, which can be used to handle both tasks. So, to use DNSMask, you need a configuration file. I'm going to include this in the resources. But before I just run it, I actually want to explain to you what's inside it, because it's very simple. And like I said, I want you to understand what's going on inside these configuration files so that you can adapt it to your own scenario. So I'm going to right-click this, and I'm just going to open it with Genie so I can zoom in. It's a normal text, so you can open it with any text editor. And I've added comments here to tell you what each of these lines does. So anything that's preceded with the hashtag here means it's a comment. It's not going to be read by the program. It's just a way for me to tell you what's this going to do. So you can see the first line here sets the interface. So I have that set to LAN 0. That's the name of my interface in here. As you can see, that's the name of my wireless interface. Then we set the IP range that we can give to our clients. And you can see that's set from 10.0.0.10 to 10.0.0.100. And each of these IPs can last for 8 hours. Then we set the IP of the gateway. So that's going to be the IP of my LAN 0 after I start the fake access point. And that's going to be set to 10.0.0.1. And as you might know, we usually use the first IP for the gateway or for the router. Then we set the IP for the DNS server, and again that's sent to 10.0.0.1, which is the IP of my computer, the IP of the router in this fake access point. The last line here is very important, and this will redirect any request that anyone makes on this fake access point to the IP of the router to 10.0.0.1. So we're using the hashtag here, which means that we're redirecting any requests to any web page to the IP of my computer. Now, if you look at the result of ifconfig right now, you'll see that I still don't have an IP address, but once I start the network, I'm going to configure it to have an IP of 10.0.0.1. Now, this is very similar to doing a DNS spoofing attack, but instead of using another tool to do that, we can just do it through the DNS server right here, because we're going to be already the man in the middle, because we're already the people that's broadcasting the signal that's making the access point. So I'm going to close it, and I'm going to start DNSMask. So first, in here, I'm just going to clear this. And then I'm going to do DNSMask. And then I'm going to do -c to specify the location where I have my configuration file. And as you can see in here, my configuration file is in home, downloads, fake AP. So it's going to be root, because in Kali, home is set to root. And it's downloads, fake AP. And the name of my file is called dnsmask.conf. So, we're doing DNSMask, -c, the location where we have our configuration file. Okay, now that got executed with no errors. This means that now we have a DNS server and a DHCP server running in the background as a service. So, if we go back to our slide in here, we can see that we have steps 2 and 3 already done. And all we have to do now is just create a fake access point. That's going to broadcast our signal. So let's go back to the Kali machine. And before we start our fake access point, I want to show you the configuration file that it uses. So just like DNSMask, it uses a configuration file. So I'm just going to right click it in here. Again, I'm going to include it in the resources. And then I'm going to open it in Genie so I can zoom in. And as you can see in here, it's a very simple file, has just few lines. I have the comments here to tell you what each of these lines does. And you can see now the first line is the interface that we're using. And again, I'm setting it to LAN 0 because that's the name of my wireless adapter. The second line sets the name of the network. So you want to set this to a name that's similar to the network that you're targeting, if you're targeting a captive portal, or you need to set it to the same name if you're trying to target a normal network with WPA encryption. So in my case, I'm doing this against the captive portal, and the name of the captive portal was Royal Wi-Fi. So I'm going to set this to the same name, and I'm just going to call it version 2, so that when people get disconnected from the proper Royal Wi-Fi, because we're going to do a de-authentication attack, they'll think that there is something wrong with that network, and then they'll try to connect to this one thinking this is an updated version of it. Okay, now I'm going to save this. The next line sets the channel that this network will be broadcasting on. I'm going to leave it at 1. And the last line says the driver to be used for the interface adapter, and I'm going to leave it. Now everything is done. Again, I'm going to close this, and I'm going to start the host APD network by doing host APD, followed by the name of the configuration file, so it's stored in root, downloads, fake AP, and it's called hostapd.conf. And I'm also going to add -b to the end, because usually when you run this command without the -b, it'll run as a command in the foreground, and you'll have to open a new terminal window to run commands from. So I'm doing -b at the end, so that if I hit enter, it will be executed at the background, and then I'll be able to run more commands in the terminal. Now, as you can see, it's telling us that the network is working, and it's broadcasting under the name Royal Wi-Fi version 2. Now, finally, I'm going to configure my LAN 0, my wireless adapter, to have an IP address. I'm going to set that IP address to 10.0.0.1, and then I'm going to set its net mask. So first of all, if I just do ifconfig LAN 0 now, you'll see that it still doesn't have an IP address. So we're going to do ifconfig LAN 0. We're going to give it an IP address of 10.0.0.1. And I chose this IP address because this is the IP that I'm using in DNS mask configuration as the IP address of the router, as the IP address of the DNS server, and as the IP address that all the requests should go to. Then I'm going to do netmask, and I'm going to set that to 255.255.255.0, which is the default. Okay, so we're literally just configuring our wireless adapter to have an IP address, and we're setting ignat mask as well. I'm going to hit enter, and we're done. We're completely done. Now we have our host APD running, broadcasting the wireless signal, so we have a network running with this name, Royal Wi-Fi version 2. We also started our DNS server, so now we have any device that connects to our network will get an IP address, and they'll be able to use that network. Now the last thing that we need to do is start Apache, which is the web server that has the fake login page. So we usually start Apache by doing service Apache 2 start. And that starts Apache for us. Now, let's go to a Windows machine and test this network and see if it actually works. Now, I'm going to go on Wi-Fi. And as you can see, we have two Royal Wi-Fi networks. We have the original one right here, and we have the fake one. Now, in a proper attack scenario, you should be running the authentication attack against this network so that nobody can connect to it, and even the people connected to it will lose their connection. So once that happens, they're going to look for Wi-Fi networks, and they're going to see a network called Royal Wi-Fi version 2, and they'll just think this is an updated version of their network. They're going to try to connect. And usually when they connect, they get a login screen that looks similar to what they usually do. Now, this is not going to happen right now, and I'll tell you why, and I'm going to fix that in future lectures. But for now, we're just going to connect to make sure that we can connect to this network. And once we connect, I'm going to go and open my web browser. And just go to any web page. So I'm going to go to bing.com. Now, once we do that, as you can see, we automatically got redirected to the login page that looks exactly like the login page that our target uses. And they can just click English, click on login, and then put their information and submit it. Now, ideally, we'd like this to be automatically displayed to the users as soon as they connect, because that's the default or the usual behavior of captive portals. When you connect to it on an iPhone, on a smartphone, or even on a computer, the login page automatically gets displayed to you, and we want our users to get the exact same experience so they don't get suspicious. So what we've done so far is really good. Now, if you try to go to any website in here, it's redirecting you to the login page, but the login page is not being displayed automatically. Another issue, if you try to go to a web page that uses HSTS, like Facebook for example, the browser will refuse to load it because it knows that this website uses HTTPS and you're not accessing it using HTTPS, so it's showing an error. That's another problem that might make people suspicious, so we're going to address both of these issues later on in future lectures. But for now, as you can see, we have a working network that has a name, people can connect to it, and anytime they try to go to any website, they'll be redirected to the login page right here. Our next video is redirecting requests to captive portal login page. Thank you.